Welcome to Rges, Algebra 1, Lesson 11A. This is covering units 5.9 to 5.10, factoring trinomial squares. Now recall that if you had a binomial, let's say you have x plus 5, and you square the entire thing, that works out. You could either write it out with parentheses, two binomials, and square it with FOIL, or you can remember that it is the same as the first term squared, the two terms multiplied together and doubled, that'd be 5x and 5x, or 10x, and the last term squared. Now notice if I had x minus 5 squared, I would also get x squared, but in this case the middle terms, or the two terms multiplied together, would give me negative 5x, and that doubled would give me negative 10x, and the last term would be the negative 5 squared, or plus 25. Okay, so the only thing that differs between example 1 and example 2 is this negative sign right there. Okay, so that's going to be important. Now, what we're going to do in this unit is we're going to work from here backwards to see if we can get that. In other words, can we work with a perfect square or a trinomial square to get a binomial, to factor as a binomial squared? Okay, well, let's take a look at what we would need to see. Let's say we have what I'm going to look for is two key ideas. First off, can this be something squared? Yes, that's an x squared. Is that something squared, an even whole number? And it's a 6 squared. When I multiply these together, so that's the first step, is my first and last term something squared? Of course, this would be a plus sign here. And now when I multiply it together and double it, because of what I just saw above, 6x doubled, is that the middle term? So that's my second question. And because it is, this factors to that. And that's all there is to it. Let's do another one. Can this be something squared? Can this be something squared? When I multiply them together with a negative sign, I would get negative 9x, double it, I would get 18x, so that does indeed factor to that. And that's all you're doing. You're looking for these conditions, condition number 1 and condition number 2. If it follows that pattern, you can factor it back. So let's do a little bit of practice. Before I do my practice, let's just make sure we know our squares. You should know them through 15 automatically. So I've given you the chart of the squares all the way up through 15, and that's all I care that you know. I don't care. I won't be giving them to you, problems to you with larger numbers, so you won't have to use the calculator as he's showing you to determine whether a number is an even square. So if I have let's say 169, and a whole number times the whole number equals, or a number squared equals that, certainly does, 13 squared, then we would call this a rational number. But if I have, let's say, just 170, doesn't have to be off by a lot, but that does not equal a integer squared, then this is going to be called irrational. Okay, and it's not a perfect square. Okay, I can talk about other things later, but at least for our purposes, it's not necessarily a single integer, but let's just, for your purposes right now, think of it that way. Okay, if I have a square root of a negative number, whether it can be written, this can be written as a integer squared or not, if I multiplied a 13 by 13, I would not get negative, and if I multiplied a negative 13 by negative 13, I would not get a negative under the square root. So this is called an imaginary number, or for his purposes, for your homework, both are irrational, because an imaginary, well, we'll leave it at that. Okay, so you can just label them not rational, irrational. Okay, so he's just asking you for your first set of homework. In fact, I would go to page 203 and I would look at A through J and make sure you could just answer those very quickly. Either it's not a real number or give the real number. Now, what if I had this? One more example here. That would equal, so the square root of, if I had these four problems here. The first one, the answer would be 13. The second one, it would be not real. Okay. The third one, it would be not real. And the fourth one, it would be a negative 13, because we'll take the answer under here, which is 13, and then we apply the negative sign. Okay, so you should be able to fly through those very quickly orally. Skip K through Y, I'm not interested in that, and then go down to problems 1 through 21. Now, you're going to do the odd ones there, so let me show you a couple of the even ones. They're just asking you, is it a trinomial? Can it be written as a square of a binomial? Or if not, or tell why it is not a trinomial square. Okay, so let's do a couple of these. So either write it, I'm going to do a couple of the even ones here. Let me pause. So on 5.9, all I want you to do is write it down and then write it as a square. I would be thinking, yes, it could be an X. Yes, it could be a 6. The sign would have to be negative. And when I multiply and double, do I get this? Yes. And so the answer would be that. The next one, so you're doing this pretty much in your head. Square root of 16 is 4. I would have a plus in between. 4x doubled is 8x, so this works. The next one, I would have an x. I would have a 7. I would have a negative sign in between, negative 7x. Is that negative 14x? Yes, and so this works. The next one, I would have an x. I would have a 6. I would have a negative. If I multiplied it together, I would get negative, and doubled it, I get negative 12. Do I have that? No. So at this point, just stop. Don't finish it off on the right, and circle what's wrong. Circle the part that's wrong. This is, whoops, I could include the sign. This is what's wrong right there, and that's all you have to do as far as I'm concerned. Identify it's wrong, or write it as a binomial squared. Goodness. All right, let's see what else I want to talk about. Let's go to the next page and go down to page 30, or number 35 on page 204. This is still in 5.9. So again, grab your book to page 204, number 35. What I have here is a 4 with 2 zeros. So does what times what equals 4? A 2. And if I had a 0 in the first one, 20 times 20 would equal 2 times 2, or 4, with 2 zeros. So this would indeed be 20. Okay, square root of 400 is 20. And this would be x. If I multiply it together and get 20x, I'd have to double that. And that does not equal 40. So this is a problem here. So that cannot be changed or factored into a binomial squared. Number 37. I just want to talk through these larger numbers here. I've got 2 zeros and 2 zeros, and what times what equals 1? A 1. So if I have a 100 squared, that would be 1 and 4 zeros. So this becomes 10,000 is 100 squared. Okay. So if I think of the 100 and that, if I minus sign, multiply them together, I get 100x, double it, I get negative 200, and that would indeed do fine. 39, we have x squared plus 100x plus 10,000. 1,000. Now, just thinking about this logically, you don't need a calculator to think about this. I'm going to look at this one, and I have 3 zeros. That's not an even number of zeros. So is there, let's say if I have a 10 times 10, I get 100. If I have 100 squared, I get, as we just showed you, 10,000, 4 zeros. So I don't have a number that could multiply together to give me 1 there with a certain number of zeros. That would be an even square. So this is the problem, and I cannot factor this into a binomial squared. And then let's go, after you've done your homework, come back to this tape or put it on pause to do your 41 through 52, or 41 through 50, and then 52. And I am going to write down the answers to these even problems for you. So come back to the tape to check the answers to the even problems when you're doing 41 through 50 and 52. The odd problems, of course, you can check in the back of the book. So here are your answers to those even problems, beginning with 42 through 50. And now let's look at 52 together. These now have a number in front of the first. Let's look at A. They have a number in front of the first variable. But other than that, the thinking is exactly the same. I'm going to look at, we're trying to decide, can this be a binomial square as a fact when it's factored? Well, 9x squared could be factored to 3x times 3x, right? So that would be the first term, square root. The last one would be 4. If I multiplied it together, I'd get 12x, same idea. Doubled it, I get 24x. So yes, that factors to that, just like that. I'm going to do a few more for you and then give you the answers to the rest. So that would be the answer to A. Let's make that a little neater here. Let's circle that answer. B, 25x squared minus 70x plus 49. We have a 5x if we square it. We have a 7. 7 if we take the square root of 49. We take them negative in the middle. 35x doubled would be 70x. And so this would square. So continue on just like that, but 2 of them will not square. So try to get your answers for the rest, C through H. And remember that 2 do not square, or do not become, do not produce when they're factored binomial squares. Okay, so come in with any questions on that. For 5.10, we just have some very quick determining whether or not it's an even square root or a rational number when you take the square root or not. Go ahead and do those 31 through 54 all, and we will give the answers in class and make sure there are no questions.